Hello everyone and welcome back to another video. Today we'll be continuing with our look into the new chess engine, which we'll be making over the course of the next couple of videos. And today we'll be taking a deep dive into the legal moves, which we started last time. And we'll be taking a look in particular at the castle and legal moves functions. So let's just have a look at the actual program. So if you want to follow along on GitHub, as I would recommend you do, the castle and legal moves are down here from lines 250 to 270. Okay, so let's have a look at the castle one first. Pretty much, what the castle function does is it determines whether castling in a certain direction is valid or not. So, as you know in chess, we can either castle kingside or queenside, and obviously either black or white can castle. So then, which is why the parameters passed to this are first of all the color, black or white, and then second of all the direction. So which direction, kingside or queenside, and obviously board and piece locations. So if you notice, board and piece locations are passed to almost like all of the major functions, since it's required for almost everything required to know where the pieces are inside the board. Okay, so first of all, we start by initializing the king position. Since this varies, the starting king position can vary depending on which color you are. And then one important thing in chess is that you cannot castle through check. So what exactly does this mean? That means that if you're currently in check, then you can't castle. And then you also can't castle if any of the moves leading to the final king position are in check. So that might be a bit of a mouthful, but let me just give a quick example with this position. So in this particular position, castling is indeed valid because the king is not in check, and none of the squares leading up to the check are also going to place the king in check. But then, for example, if black were to take my knight over here, then the king would be in check, so I couldn't castle. Okay? And additionally, for example, let's say this knight was here instead. So that means that I also couldn't castle, since moving this king from here to here would result in this particular square being check. So that is invalid. So these are basically the considerations which we need to take inside our program. So first of all, depending on which king position it is, kingside or queenside, then we update the rook position accordingly. So if it's kingside, then the original rook position is going to be the king position, and then the same row as the king position, but then the 7th column. And then otherwise, it's going to be the first column. So either the leftmost or the rightmost column. Okay. So and one more thing is these positions. So what these position variables are is it's basically an array of all the different positions which the king will occupy in its traversal from its original position to its final position. Since what we need to check is that none of these positions place the king in check. Okay. So what we do is for positions, the result equals is under severe attack, position board. So what this is under severe attack does is it basically checks if the king is within check, and we'll be going over this is under severe attack function in much more detail in the upcoming videos. But then for now, or you can just think of it as it checks whether a certain coordinate is under attack, effectively. And then it returns true if it is under attack. So if it's true, or if the board position is already occupied, i.e. there is a bishop or a knight or like some piece in the way preventing the castle, then we basically make castle through check true. So this basically means that castling is invalid, and then we break. Okay, and then after we basically return this particular Boolean variable, and this just means that whether castling is true or not, like whether you can castle or not. And the conditions for this are, first of all, if you are not castling through check, and the second condition is that this particular long string of conditions. So let's break this up. So the first one is that if the rook position is equal to the starting position and the ending position. So what this means is that whether the rook is originally in the starting place, and whether the king is originally in the ending place. Okay, so if both these conditions are met, as well as not castling through check, then the king can indeed castle in that particular side of the board. Okay, and now it's also worth mentioning that some small addition which I made since the previous video for the foundation functions was with the move function, since the previous implementation was a bit clunky in the way I implemented castling, so I've decided to change it like so. So pretty much how it works is this particular Boolean condition just checks whether castling is met. So if the piece number is a king, and if the final arrangement and the original arrangement are 2 away from each other. If both these are met, then we basically know that the king will be castling. And out of the king's castling, then we don't only need to update the king's position, but we also need to update the position of the rook. So what exactly does this mean? So the new p1 and new p2 are basically the 2 positions of the rook, the final and initial arrangements of the rook. So if it's castling king side, then it will basically enter this particular loop. So that basically means that the original rook position is on the 7th column, and the new rook position is on the 5th column. But if it's castling queen side, then the original rook position will be on the 1st column, and the final rook position will be on the 3rd column. And now what this means is that we then recursively call the move function on the new p1 and new p2, where new p1 and new p2 are the final and initial arrangements of the rook. And then this updates the piece locations and grid copy accordingly, and then we can finally return this, which is updated with the new values. So, sorry about that change which I made, and I didn't cover that in the foundation functions, but we have that change made now. So let's just see the actual castling function in action. So if we go back here, and then if we move our king here, we can indeed see that it works. And then the game will just continue as normal after that. So now if we go back to our program, we have to cover the second function, which we're going to go through today. And this function is basically the legal moves function. So yeah, as discussed previously, not all possible moves are necessarily legal. So for example, if we go back to our board over here, we know that certain moves aren't necessarily legal. So for example, let's say if black were to play knight check over here, then one of the possible moves which we could do is moving the rook over here. However, that isn't a legal move since we're currently going to be in check. Okay, so we need to basically address situations like that, preventing either player from making it a legal move. Okay, so now let's go back to our program. So legal moves basically possible array is the possible moves from that particular coordinate inside the board, and is check and attack square. This is part of the king info. And now you might be wondering, where is this king info coming from? So this king info is actually being passed from one of our core functions, which we'll be going through in a later video. But for now, you can think of king info as just information about the king's position and whether it's in check or not. So it has 2 main pins, is first of all whether it's in check, and second of all, which square is the check coming from. So is check and attack square. So if the attack square is present, i.e. there is an attack square, then we first check whether it's pinned. So is pinned is another it is basically another array which is being passed from the core functions. And then what we'll be doing is possible. We'll be doing this following list comprehension. So what this means is if the piece is pinned, then we can only do the moves in possible if the move is basically attacking the attack square. Since if we go back to the board as an example, if a particular piece is pinned, so let's say the knight is pinned to the queen, then let's just treat the queen as a king in this particular position. So this means that the knight can't actually move anywhere, since every possible move it will be making will be placing the queen under danger. But then let's say if this knight was actually a bishop instead, then the only move the bishop could make is taking this bishop. since that's the only move which relieves the pin. So that's basically the logic which we have inside here. So for move in pin, we basically do possible for move in possible if the square is attacking the attacked square. And now that's if it's pinned, but if it's check, then we basically do possible for pause and possible. If possible, is it allowed? And now allowed is basically another array, which we go through in another video, which is basically the list of all the allowed coordinates which the king can go through. Or, sorry, not the king, which the piece can go through. Okay, and then finally we just return this possible array. So that's pretty much it for the legal moves and castle functions. And that basically wraps up today's video. I really hope you enjoyed watching the video. Hopefully you learned something new about either function and the way in which we implemented it. If you enjoyed the video, please be sure to leave a like and subscribe. And I thank you very much for watching this far. And I hope to see you in another video next time. Bye.